Hi, my name is Haikal. So today I'm going to talk about the flight test briefing for Albatros drone. So for the first slide, I'm going to talk about the sensible range of value of center of mass. So the default value of center of mass is 0.01 meter from the leading edge of MSE, but there is the recommended range of value of center of mass, and it is as follows. For the minimum value of center of mass is 0.1165 meter from the leading edge of MSE, while the maximum value of center of mass is 0.165 meter from the leading edge of MSE. And for this slide is the thrust measurement graph. So a calibrated motor speed next sekali. Hi, my name is Momo Aikel. So I'm going to brief about the flight test for Albatros drone. So for the first slide, I'm going to talk about the sensible range of value for the center of mass of the Albatros drone. So as default, the value is 0.01 meter from the leading edge of MSE. But after through weight and balance method in determining a new range value of COM, the new value of center of mass is as follow, which is having a value of 0.1165 meter as the minimum value of COM, while a maximum value of 0.165 meter. And this graph is a graph about static thrust against calibrated motor speed. And as you can see, for the RPM below 2000, the static thrust have a really low of thrust, while for the RPM above 2000, the static thrust seems to grow exponentially. And this slide is just show about the flight control configuration, in which the movement of lateral, longitudinal, vertical axis of Albatros, and it is because of the mechanical part that cause the Albatros to pitch, roll, yaw, and roll and yaw. So for this section is the longitudinal dynamic response. So as the aircraft pitch upwards, the angle of attack is positive and the flap is deflected downwards. And for the elevator, if the aircraft is pitching up, the elevator is deflected upwards and is considered a negative deflection. It can be shown on the diagram. A positive value of angle of attack is in synchronous with the negative value of elevator angle. So in terms of velocity and center of mass, as the value of velocity increases, the pitch response goes from a low rate of response to a significant response, while for the center of mass, it was inverted, which is from a significant response to a stable response. And in terms of the short period of frequency obtained through this simulation is 0.5, while the one in theoretical analysis is 13.35. And for the damping ratio, the value is below 1, and again for the value in theoretical analysis is 0.804. And before I forget, so the acceptable center of mass position for acceptable pitch control are between 38.62 to 39.43%. So in terms of the lateral dynamic response, as the free stream velocity increases, the roll rate of the Albatros is increased. And secondly, as the rudder yaw to the left, the value of the side slip angle is positive, and vice versa. And thirdly, the damping yaw have a higher damping time than the damping pitch. And in terms of the flight performance, for each flap deflection, the lift coefficient experienced by the wing of the Albatros is different, and each flight deflection have their own max lift coefficient point. But beyond the 10 degree of angle of attack, all the lift coefficient value is reduced. And the lowest lift coefficient produced due to the lap is 0.993, while the highest lift coefficient is 1.298. And for the CL against CD plot, the different flap deflection produce different value of CL and CD values, but all CD almost converge above a value of CD above 0.1. So in terms of lift to drag ratio, the best value of maximum lift to drag is at 30.65 for a value of 0.48 of lift coefficient. Thus, the value produced for this graph is lower than the manufacturer's data. And for the pitching moment against lift coefficient, the best elevated angle to trim is at elevated deflection of -5 degree, because it produces the high pitching moment, hence help in trim the aircraft faster. So in terms of pitch stability, the neutral point does not show any changes to the pitching moment, because it should be between 0.35 and 0.6, which is at position 0.5. So for ground handling and minimal unstick speed, so the first video is the ground handling. So the movement of the albatross on the ground is based on the propeller and rudder, and the propeller is responsible in providing the thrust, while the rudder is responsible for the change in direction. And the high amount of thrust will cause the difficulties in handling the plane, such as high amount of steering will cause the plane to tilt overdue to uneven surfaces. In terms of for the second video, which is the minimal unstick speed, so for the second video, the minimum speed needed to take off without flaps is 35 meter per second, while the minimum speed needed to take off with flaps is 27 meter per second, and the predicted velocity stall is 10.55 meter per second, which is lower than the minimum takeoff speed with or without flaps. So the third video is the cruise trim at a velocity of 20 milliseconds. So the port elevator obtained is 1.27 meter, while the starport elevator deflection is 1.27 meter. The throttle setting is at 4,873 RPM. And for the fourth video, is the lowest is the low cruise trim, in which I have obtained the lowest achievable velocity at 17 meter per second, and the throttle setting was 4,142 RPM, and the port elevator is as shown below. And in terms of the maximum trim flight, which is this video, the highest achievable maximum velocity is 46 meter per second, and in terms of the throttle setting, port elevator and starport elevator is as shown in the slides. So last one is the drone maneuver for the task number 16. So the drone is basically in the process of having a trim of velocity value of 26 meter per second. Thank you.